Alright, hey guys, Pogo here, and welcome to episode 3 of the RPG Game Jam. First of all, for those of you, if you are watching it live, I am sorry about the confusion. I know that we did not have it yesterday because I was busy and I just didn't have any time to do it, and then I didn't confirm the time until, about 2 hours before the stream today started, so if you did miss it and you wanted to come, I'm sorry, and I know it's my fault. Of course, you're probably watching this on YouTube, and, you can still catch up and whatever. This video is going to be longer. It'll probably be around an hour and a half, because I did skip yesterday. I was not able to do it, so I'm going to try to make up for it and do it today. Now, as always, the GitHub repository is up. It is on my YouTube account, Pogo629dev, and it's called RPG29, and you can head over there to check out the code. I will be pushing there occasionally throughout the video so you can keep up, and of course, this will always have at the very end all of the code from the day, the latest day, so you can always get the latest code to, check your own code or do whatever you want with it if you want to even at the end adapt it and make your own version of the game. So that is where you can find that. Alright, so today is going to be a pretty interesting day because the first thing we're going to do is set up our entity system so that we can have players and I guess other entities spawn into the game and be displayed. Then we're actually going to work on, getting a player to move. So we'll have the player spawn where they're supposed to spawn, then pressing the up, down, left, and right keys will cause them to move around. Then we'll also have it where if they press enter, it'll cause them to interact with the tile right in front of them in whatever direction they're looking. And then eventually, either today or tomorrow, we're going to write a little event system so that you can actually register and listen to events. So when a player moves or a player interacts with a tile or, other events, and you can easily make your own. And, excuse me, so we'll get to that, and that's going to be one of the cooler and one of my favorite parts of this game because the event system that I have planned out is actually pretty cool. Ninja Tiger X7 asks, where did you learn how to code? If you want to know where I learned how to code, my 500 subscriber special was like basically kind of a history of my coding, so if you're interested in learning, check it out. It kind of just goes through, starting out little with basic program and then getting more and more advanced into it. So I would definitely recommend checking it out if you are interested. That will explain everything better than I can explain right now. And I believe that's all we need to do there. Alright, so we're going to go ahead and set up the entity class, which is going to represent an entity. It'll load in all of the images, and then it will, contain all of the information, and also the walk cycle. Basically, if you play any game, you'll notice that the player, when you move, the player will step, and they kind of have like a little movement where they will, step to the left and right, and you get like a little animation, and we want to have this in the walk cycle so that it doesn't look like there's just a static player, and then also doesn't look like the player keeps stepping with the same foot, because that would be kind of weird. We're going to implement it so that they'll step with one foot, then the other foot, then the first foot, then the second foot, and it'll look more or less natural as a 32 by 32 pixelized person walking could possibly look. And crowned comedian who requests a high five. There you are. Alright, so let's go ahead and create a new package, which we are, create a new package, which we are going to call entity, and first we're going to write the entity base class, called entity. Then what we're going to do is we're going to actually be able to write other classes that extend entity. Now, it depends on the particular game that you're writing, because for this, or at least as far as we're going to get right now, we're only going to have players and then also probably NPCs which you could consider players and NPCs to be the same class, but you know, it's up to you. So we have the entity class, and then you can extend it to easily have different types of entities if you wanted to add more. So before we start, we actually need to make one enumerator, and it's going to be called direction. And we'll go ahead and put this in map. And we're going to create an enum or enumerator called direction. This enumerator is basically going to represent a direction, which would be, I believe, up, down, left, and right. And then it's also going to have a bunch of helpful methods for, you know, calculating different things that we need to know. So first we're going to define the constants, which are left, up, right, and down. Those just represent the four directions. I guess you could use north, south, east, and west, but we're really doing this for, like, you know, the way that the player's facing. We're going to go ahead and add a public static direction value of int key code. Now, when we go to add the key listener for checking when the player presses a key and then figuring out what key they pressed, each key has its own code, which is defined inside of the key event class. So what we're going to do here is we have an easy matching method. So if I want to figure out the direction, and let's say I press the up button, and I give it the key code for up, then it should return the up constant inside of direction. It's just like an easy way of doing it. So what we're going to go ahead and do, excuse me, is we're going to say if key code is equal to key event.vk up. The way that key event codes work is they're all defined in the key event class, and they're prefixed with vk underscore. So whatever you're looking for, if it's vk up or vk whatever letter or number you're looking for, that's where you would find it. So if they pressed up, then you would want to return direction.up. So if the key that we're giving them is up, we want to return up. Else if key code is equal to key event.vk down, return direction.down. Else if key code is equal to key event.vk left, then we'll return direction.left. And else if key code is equal to key event.vk right, return direction.right, else return null. So if they give us something that's not a valid key, or if it's not up, down, left, or right, then we just want to return null. And one thing that I quickly want to do for my own sanity is reorganize these so that they match up with this order. So it's left, up, and then it's right, and then down. No, it's right, and then down. So that's in the correct order. Okay, so now, that was just a static method, which I'm actually going to put at the bottom because that doesn't have anything to do with the personal direction. So that's static, and it's for getting an instance of this direction, or a constant from it. Now we're going to write some methods that will require you to already have a direction in order to use them. So what this means is that if this static method means that I could just call direction.valueof. But these next, I believe we're going to write two more methods that will actually require you to pick your direction before you can use them. And this will make more sense eventually when we go to add the location, or when we go to add the movement. Sorry. So the first thing we're going to do is we're going to write a public point called getMovement, and that's it. Since we already have an instance of direction, then we know where we currently are. And we're going to go ahead and use a switch statement just because in this case it's easier. And we're going to type in values ordinal like that. And make sure that values has those parentheses. What this is doing is we're going through, so values returns all of the different values. So in this case, left, up, right, down. Now ordinal, and values is static. Ordinal is non-static and represents the number of the current, of the thing that you're using. So in this case, if I were to call get movement on left, then ordinal would be 0. So then it would get values at position 0, which would be left. So this is how you can actually figure out what the chosen direction is in a non-static context. So we're going to go ahead and say case left. So if this is left, then we're going to return new point 0, -1. The way that this works is it's going to, the way that this works is it's going to, this point, which remember is just an x and a y, it's just a wrapper that contains an x and a y, we're going to figure out in which direction a player should move. So in this case, the x should change by 0 and the y should change by -1. This is how we figure out which way to move the player based on where they're currently looking. Because when they go to move, we figure out where they currently are looking, or where they want to move, rather, and then we figure out the tile where they should go based on where they want to go, the direction that they want to go. So in this case, it moves the y by -1. Then we want to say case up, return new point. If I could type, return new point. Yes. And this is going to be -1 and 0. That means change the x by -1 and change the y by 0. Then we're going to do case right, which will return new point. And this should be 0 and 1. So change the x by +1. Then case down will be return new point. And down would be 1, 0. So change the x by +1 and the y by 0. We just need to do the default return null. That would never happen, but we just need to have it, or else the method does not return anything. Before I continue, Ninja Tiger X7 asks, what languages do I know besides Java, or is Java the only programming language that I know? As of right now, Java is the only language that I really know. And that's basically, yeah, I don't really know any other languages. It's not that I haven't thought of learning them, it's just that I have been a bit busy recently. I would definitely consider looking into, C or another language probably similar to Java. But I have not yet up to this point. Java is the sole language that I use, and it does accomplish everything that I've needed up to this point perfectly. So Java is the only language that I use. Let's go ahead and continue. The last method that we need in here is called public point get point relative to, called point, and we're going to take point P. What this does is it will return the point that is next to the given point in the direction that we currently want. So if say that the direction is left, and then I pass it a point, it would return the point to the left of that current point. And this is going to be important. So we can basically just copy this thing right here, but there are a couple of things that we need to change. So if the case is left, then we're going to return p.x and then p.y -1. And you'll notice that it's very similar. We're basically just adding in p.x -1, and then instead of 0 it would be p.y. Then over here we are just doing p.x, so it would still be p.x, but then here we're adding 1 to the y. It's pretty much the same thing. It's just basically a utility that makes it easier. So then we're going to add 1 to there, and then p.y is going to stay the same. And that's all that we need to do for direction, and that will definitely come in handy eventually. Now, in the entity class, we're going to go ahead and declare a bunch of make a bunch of instance variables. The first one, and this is going to be confusing, so get ready for this. Private hash map, direction, hash map, integer, image icon, images. Now, I'm going to take a second to explain that. First, we need to import everything. Okay. What we're doing here, this images is basically going to contain all of the images for the entity. Now, the first, it's a hash map that contains a direction and then a hash map of integer and image icon. So the direction is basically, you know, the current orientation or direction. So let's say I plug in left. Then this would contain, you know, all of the images that are to the left. Integer represents the walk cycle. If it's 0, it means that they're standing still. If it's 1, it means it's the first foot is out. And if it's 2, it means that the second foot is out. And then that finally corresponds to an image icon. So if I plugged in left and 0, it would return the image of the entity facing to the left and not moving at all. If I plugged in down and 1, it would return the image of the entity facing down with the first leg out. And that's how we're going to basically store all of the images. We also need a private hash map direction integer called walk cycle. This is going to store the walk cycle for each direction. So if I'm walking down, then it'll store the current cycle, whether it's 1 or 2, so that whenever I go down, it doesn't always use the same foot, and that's how we keep track of it for each direction. Then we also need a private image icon called current image. That's going to be the current image that the entity is using. Then we need a private direction, current direction. That's going to be the current direction in which the entity is facing. And then a private location called current location. That's going to be the current location of the entity so that we know where they are. We're then going to make the constructor called public entity, and it's basically going to take in a string called name. First, we need to go ahead and instantiate images is equal to new hash map direction hash map integer okay, image icon. So we're first instantiating image, and then we also need to do the walk cycle. So walk cycle is equal to new hash map direction integer. Alright, there we go. Alright, so we have images instantiated and walk cycle instantiated. So now we're going to go ahead and define the tile sheet. Now, before we do this, I'm going to go ahead and grab the tile sheet that we're going to be using because for the player, we're going to actually use a tile sheet. So in the resources folder, we're going to go ahead and create a new package, and we're going to call this sprites. Now, if you don't know, a sprite in game coding is basically just like a little image that shows up that represents, I believe it's made to represent a player. So then under that, we're going to make a sub-package called player, since the first thing we're going to make is the sprite for the player. Then we need the tile sheet, which I just went ahead and grabbed. And again, this will be in the GitHub repository. But if you go ahead and take a look at it, you might recognize this as it was borrowed from Pokemon or some modification to a Pokemon game. So what we have here is 32 by 32 images, so that, and they're all in one image, so that we can use the same tile sheet class as we used before. The first 3 images are the up images. I think it's still 1, 2. Then it's to the right, 0, 1, 2, left 0, 1, 2, and down 0, 1, 2. So that's how I'm storing them. And if you go ahead and define your own player, which I would definitely recommend doing if you were going to do anything with this, then you would need to make sure that either they are assembled in the same way as this, or that you update the code so that it will actually that it will reflect the correct orientation or layout of the images. So that's how we are going to do this. And it looks, if you take a look at the environment, they are all, 32 by 32 and spread out in the same way. So we now have this right here. So give me 1 second, and let's go ahead and get started on the entity. So we're going to go ahead and say tile sheet T is equal to new tile sheet, and this is going to take sprites slash name.toLowercase, and then tile sheet.png. And hang on, how did we do this? So we said that the name was just, so we're just gonna do like that. Should work. So we're instantiating a tile sheet with the image found in sprites and then player. So if I instantiated an entity and the name was player, then it would go to player and then tile sheet.png. So when you give it the name, like say you made one called, you know, sheep, then you would have under sprites you would have a folder called sheep, and then you would have tile sheet.png that would contain all of the images that would be needed for the sheep, and then it would work the same way. Now we are going to go ahead and write a quick method called private void add images, direction D, image icon 0, image icon 1, and image icon 2. What this is going to do is it's just going to basically put in it's just going to put in the images for that direction. It's just instead of copying and pasting the same thing for all 4 directions, writing one method to do it is just easier. So first we need to go ahead and say hash map, and this is going to be an integer and image icon called, and we're just going to call it int icon since it contains an integer and then an image icon, is equal to new hash map integer and image icon. And okay, so we're going to go ahead and say int icon dot put 0 and then 0, int icon dot put number 1 and then the 1 image icon, int icon dot put 2 and then 2, then images dot put d and int icon. What this is doing is we're instantiating a hash map that will contain each integer and then its corresponding image icon. We're filling it with all the information that it needs, and then we're inserting it with the given direction into the image's hash map. It's just an easier way of doing it than copying and pasting this code 4 times. So now we are going to go ahead and call this method 4 times. The first time we're going to call it is going to be direction dot, and I'm going to do this in the same order as here. So first it's going to be direction dot left, and then it takes the 3 image icons. So we're going to say t.getTile, and it takes an x and a y. So for left, it is going to be at position 1, 1, and then it's going to be t.getTile at position 2, 1, and then getTile at position 3, 1. Then we're going to go ahead and do, I believe the next one is up, direction.up, and for up, it's going to take 0, 0, then it's going to take 1, 0, and then it's going to take 2, 0. After that, I believe is right, which will be direction.right, and for right, it's going to take 3, 0, then it's going to take 4, 0, and finally it's going to take 0, 1. And finally we just have down, and then down is going to take 4, 1, it's also going to take 0, 2, and then it's also going to take 1 and 2. So these are basically, we're getting the tiles for these different positions, and that is how we are going to do that. So it's just getting all of the tiles from those positions and then adding them in for the correct walk cycle. And then we are going to go ahead and say this dot current image is equal to get image for direction dot down and then false. We're going to write this get image method that will return an image for the direction that you want and then whether or not they are moving. And by default, we want to start it at them looking down and not moving. So that's how we're going to do that. So now let's actually go ahead and write that method. So it's going to be a public image icon called getImage. It's going to take direction D and then Boolean, too many O's, Boolean moving. So first we're going to say this dot current direction is equal to D. so that we know, so that whatever the current direction is, we want to be able to keep track of the current direction. So we're setting it equal to that. So because whenever we call getImage, it's going to be when we are, changing the image, so that when they're walking, we would first get them as moving true, and then after a little delay, we would get them as moving to be false. So that is for that, and we want to set the current direction for that. Then if moving, so if they are moving, then we need to modify the walk cycle correctly. So first we're going to say if walk cycle.getD is equal to null, walk cycle.put D, and then we're going to put 2. Now what we're doing is if there's no number defined in the walk cycle, so by default the walk cycle is empty. So if the walk cycle, if it's null, if it's empty, then we need to give it a default value. So we're going to give it D, which is the direction, and then 2, because the next thing is going to say if walk cycle.get for D is equal to 1, then walk cycle.put D and 2, else walk cycle.put D and 1. So basically this is just toggling the walk cycle. So if there's nothing there, it's going to put 2, and if it's equal to 1, it's going to change it to 2, else it's going to change it to 1. So the first time it runs, it'll start as 2, but then it'll change to 1. And this is just if it's moving, then we want to change the, we want to modify the walk cycle to correctly reflect the new change, or else they would just be walking on the same foot over and over again, and that would not look right. Then we're going to say return images.getD, which will return a hash type of integer and image icon. Then we want to say .get, and then it's either we're going to say moving question mark walk cycle.getD : 0. This is called a ternary operator, and it's basically just a shorthand if statement. Moving is a boolean, so it's saying moving question mark. This is if it's true, and this is if it's false. So if moving is true, then this parameter is going to be the current state of the walk cycle. So if they are moving, then we want to get the image that corresponds to the current walk cycle. If they are not moving, then we want to get the static or still image, which is at position 0, or just image number 0. So that is how that works. Now we're just going to write a couple of getters and setters. We're going to write a public direction get current direction, which will return direction or current direction. We don't need a setter for that since it's set in get image when we want to change it. We need a public location get current location, which will return current location. Then we need a public void set location, or set current location, and this will take location lock, we'll call it. Then, before we continue, we need to actually head over to the location class and add something. So this is where it might get a little bit confusing, but location, we need to know if there's an entity on a given location. So if we have a location, then we need to know if there's an entity there. Now we could, I guess, keep track of all entities in existence and then check if they're at a current location, but that's not a good idea. So we're actually going to go ahead and add an entity field to here. And this might get a little bit confusing, but don't worry about it. First we're going to say private entity. We don't need to instantiate it in the constructor, because by default it's going to be null. We can, just by default, there's going to be no entity there. Then right under point, we're going to have a public entity called getEntity, which will return entity so we can get access to it. Then we're going to say public void setEntity, entity. This dot entity not equals this dot entity is equal to entity. Then we're going to say if entity is not equal to null, and this next part is important, and entity dot get current, not direction, dot get current location is not equal to this, entity dot set current location this. What we're doing here is when we go to set the entity at a location, so there are two ways to set the location of an entity. You could call entity.setLocation or location.setEntity. We need to have access to both of these, but we also need the location of the entity to be reflected on both places. So what we're doing is we are, first of all, setting the local entity, the entity at this location, equal to the given entity. Then, if the entity that was just given was not null, because if we want to remove the entity, we would just set it to null. If it's not null, and the current location is not already this, then we're calling set current location to this. So if we're giving it an entity, and it's not a null entity, and the current location is not already this location, then we need to set it so that it knows the current location is this location, and that's very important. You need the second part, which you'll understand in a second, or else you will get a Stack Overflow. Now, that's all that we need to do for location, so let's head back over to entity and write this set location method. We're going to say if current location is not equal to null, then current location dot set entity to be null. So if we're changing their location, then we need to change the old location to have no entity, or else the player would remain in every single location it went, or whatever entity it is. Then we're going to go ahead and say this dot current location is equal to lock, so we're getting the new current location, and it's not direction, I don't know why it keeps doing that. Current location is equal to lock, so we need to know the new current location. Then, if lock.getEntity is not equal to this, lock.setEntity this. The reason why this is important is because, and this is not getTile, it keeps doing all these things, getEntity. The reason why this is important is, let's say that we have an instance of player, and then we call setLocation and we give it a location. It will remove it from the location where it already was, it'll save the new location, then if the location of that entity is not already equal to this, then we're going to set it. What this is going to do is, remember, if the location is not already, it's going to set location. Now, if you didn't have these checks, then it would keep bouncing between the two. It would call set current location, and then this would call set entity, and it would keep going back and forth. So we have the checks in, so that once the location is correct in both places, it'll stop doing that. Otherwise, you will get a Stack Overflow, the program will quit, and it will not work. So that is very important. Then we need to go ahead and do a public image icon get current image, which will return current image. That's important for when we go ahead and start drawing things. And then we need to go ahead and say public void set current image to direction D and Boolean moving. And this method, this will say this dot current, not direction, current image is equal to get image for D and moving. So it's setting the local current image equal to whatever the correct image is given the direction and whether or not it's moving. So this is going to be important for, in the moving to set the current to the walking cycle animation and then to set it to the still so we get a little walking cycle looking animation. Alright, so that is all that we need to do in the entity class. We now have a rock solid entity class that you can use to have different entity classes extend it, or different classes extend it, and then automatically get all of their images and directions and everything figured out. It's really helpful. Now we're going to go ahead and make the player class, and watch how easy this is to just make a class that will represent the player. And since the player is an entity, we can do this in just a couple lines of code. All that we need to do is first write extends entity, and then we need to go ahead and do public player super player. Done. That's all that you need to do in order to write the player class. What we're doing here is this super thing is calling the super constructor. So this player is basically calling this constructor, and it's giving the name player, so it'll automatically run everything inside of here, given the name player, and then it'll grab the tile sheet for the player, set everything up, and then we'll all be good. Now you could store other information in here, like for example the name of the player. If you wanted to store that in here, you could. Or if you end up in the end not wanting to store anything in here, you don't technically need to make a player class unless you need to, use an instance of check. You could just instantiate entity and pass it player, as the constructor argument, but it's not terribly important right now because we're going to keep the player class. So player is done. That was, of course, easy because we spent so much time on the entity. So now we're going to go ahead, and I think we're ready to go to the GUI and start and add in the player. So we're going to go ahead over to the GUI, and in here we're going to store the player. So private player. So we're going to store the player in here. Then when we instantiate the GUI, which will happen exactly one time, we can go ahead and instantiate the player. Because we're not going to use the player until the GUI is created, because that's where the player is going to show up and where we're going to get the input for the player. So we don't need to worry about having the player instantiated until the GUI, and we know that this will only happen one time. So that is good for that. Now we have player instantiated. Then in the draw component, or paint component, down in draw tiles, we need to go ahead and do where it says draw entities. So what we're going to go ahead, and do is we are going to say if lock.getEntity is not equal to null. So if it does in fact have an entity, then we're going to go ahead and call not draw string, draw image. We're going to go ahead and draw the image of lock.getEntity .getCurrentImage .getImage, and then we're going to draw it at position I times constants .tile width and j times constants .tile height. So it's basically what we've been doing this with all of the other calls that we already have. So we can just go ahead and paste that in, and the image observer that it wants is just this. And now it should go ahead and draw it in. Now we're almost done, but the player, currently we instantiate the player, but it doesn't have a location where it belongs. So inside of the map manager, and this is subject to change, of course, but we're going to go ahead to map manager, and when we go ahead and set the current map, we take the new map, then we need to go ahead and say frame.getInstance.getGUI.getPlayer, which we will go ahead and write just a simple getter. Then we're going to say set location to map.getSpawn. Now this could change for you, but what we're doing is when we change the map, we want to set the player's location to be the spawn of that map. And of course this is subject to change, but let's go ahead and create a getter, and that will automatically generate this awesome little getter right here. And this needs to be, oh yes, it's set current location. Set current location like that. And now it should work. Let's see if we get any errors. Here we go. Cross your fingers. Alright, here we go. It's making the project. Parsing the code. Doing all the final things. And nope. We get a ton of null pointer exceptions. Let's go ahead and check out where the issue is. And it looks like the issue is in lock.getEntity.getCurrentImage.getImage. So obviously we know that the entity is not null, so it has to be the current image. Let's go ahead and say this.current image is equal to getImage for down and false. Let's just go ahead and change this to a call to set current image, just to make sure that that's not the issue. And that probably won't fix it. No, I didn't think so. Alright, so we're going to have to go ahead and track down this stack trace. So the obvious error is in getCurrentImage, which returns current image. We know that, so the issue is going to be inside of this getImage method, obviously, because that is the only place where it could really happen. So let's go ahead and take a look at this code and see. So we do set the current image. If it's moving and we don't already have something defined, then we put that in. If it's equal to 1, we change it to 2. If it's not, we change it to 1. Return images.getD.get moving, yes, get for D, otherwise for 0. So let's go ahead and add a bunch of system.out.printlns, and let's go ahead and say system.out.println images. So first we just want to make sure that images is not null, because if it is, then that is an issue, of course. And stop. So as you can see, it currently, and there we go. Okay, so you'll see that images is not null, but all of these images in here with this 0, 1, and 2, those are all null, which means that calling this get tile does not work, and therefore tile sheet is messed up. So let's go ahead and take a look at what the issue is. Ah, yes, that would do it. We're not supposed to have the .png because it automatically adds it since it's an image. And this should fix it. Yes. Alright. As you can see, the player clearly does show up here. They are rendered at position 5, 5 if you count 1, 2, 3, 4, 5. And I guess it's down a little bit, so we can take a look at that. Let's just make sure. Test. Does say to put them at 5, 5. Oh, I believe it. I'll bet that it has to do with the 0, 0 thing. Alright, so we can come back and look at that later. It's not the most important thing right now, but it does, in fact, spawn the player. Now, you'll notice, of course, that the player does not do anything. It does not interact in any way, shape, or form when I press any buttons at all, because it is just coded to appear there and look pretty. So let's go ahead and actually write in the code that will handle the movement for the player. So let's go ahead and head over. We need frame and GUI open. First, in GUI, we're going to go ahead and write the method for movement, because the GUI and the player are both in there. Everything about the movement is inside of the player, so we will, of course, go ahead and write it in there. Now, before we do this, let's go ahead and write a quick utility that will handle threading. And the reason why we want to do this is because when we go ahead and do this movement method, it's going to have to happen in not a separate thread, but it's going to have to happen sort of separately from the image, or else it'll block it from working. And then the image, you won't get that animation. It'll just not do anything, and it won't update until after it changes. So we need to go ahead and write this quick utility, which we will go ahead and call thread util, because it will have some threading related things inside of it. And in here, we want to go ahead and write public void, and we're going to call this run timer. It's going to take an int duration and a final runnable called run. We're going to go ahead and say timer t is equal to new timer. It's going to take duration, import timer, duration, and then it's also going to take in a new comma, a new action listener. Why is this not working? Oh, it's the wrong timer. It's the wrong timer class. We want to go ahead and make sure that you import javax.swing.timer. And then that should generate that. And then we just need to say run.run. Finally, we just need to say t.set repeats to be false, and t.start. So what this method is going to do, and it should be called run timer, is it's just going to be an easy way to run a quick timer. You give it the duration that you want it to wait before doing whatever's inside, and then the runnable is just what you want to happen when it's done. It's just, instead of defining the timer a bunch of times, it's an easy way to do it. And we want to go ahead and define one constant, a public static final int animate is equal to 75. I've found, I did a little bit of testing, that waiting for exactly, I guess it would be milliseconds, 75 milliseconds will give the desired walk cycle effect that we want. So we're just going to go ahead and declare that constant so that we know what we want to use in case we need it to be animated, which is what we're going to use for most of it. So that's all that we really need for the thread utility right now. Let's go ahead and write the movement. It's going to be a public void handle movement, and the only thing that we need to take is a final direction called D. We just need to know in what direction they want to move, and we can take care of everything else ourselves. First, we need to go ahead and say a Boolean called didMove, which will by default be false. That's just, it'll be true if they move, and it'll be false if they just like bump against the wall. And that'll come in handy a little bit later. We also need to know a location from, which is equal to player, get current location. So we know the current location. Then we need to know the to location, which is equal to, map manager.getInstance.getCurrent map.getLocation for d.getPoint relative to player.getLocation, your getCurrentLocation.getPoint. So what this is doing is we are getting the location on the current map that is relative to the player's current location in the direction that we want. This is where we actually use the getPoint relative to method. This is just the direction where they want to go. It's basically what is to the left, right, up, or down of where the player currently is. Now we know where they want to go to. Now, first we need to go ahead and say player.setCurrentImage to be D and true. So you want to go ahead and set the current image to be the player, the direction that they want to go, and then true, because we want to show them moving. Then we'll set it to be false soon. But first we need to go ahead and write an if statement. So we're going to say if to.getPoint.getX, not getLocation.getX is greater than or equal to 0, and new line 2.getPoint.getX is less than or equal to getSize.getWidth minus constants.tileWidth, and 2.getPoint.getY is greater than or equal to 0, and 2.getPoint.getY is less than or equal to getSize.getHeight minus constants.tileHeight. And one more thing, not two more things. Not 2.getTile.getLayer is equal to layer.on. One more. And we can actually just simplify this to say is not equal to layer.on. And 2.getEntity is equal to null. And then we need that. First, let me just clean up the code a little bit since it kind of formatted strange. But what we're doing here, this is basically checking to see if the player should or should not move. So they should move if the x is greater than or equal to 0. If it's less than 0, then it means that they're trying to move off of the screen and we need to stop them. If it's if it's greater than or equal to if it's less than 0, they're moving off. If it's greater than the size of the screen minus 1 tile, then they're trying to move off on the other side. Same for the Y. They're either trying to move off the screen at the top or off the screen at the bottom, and we need to stop that. Then, if the tile layer is not the on layer, because if the tile that they're moving to is on, like say water, then we don't want them to be able to walk onto the water unless they're Jesus Christ. So we need to make sure that it's not equal to the on layer. And then finally, if the entity at that location is not null, then we don't want them to walk into the entity at that location. So if it is equal to null, then we want to allow them to do it. Finally, if they meet all of these conditions, we can call player.setLocation or setCurrentLocation to 2, and then didMove is equal to true. And we might need to, okay. So what we're doing here is if they pass everything, then we're setting the correct location We're setting it to the new location, and then did move is true, so we know that they did move. Now, we need to go ahead and call thread util, and I forgot to make this static. We need to go ahead and call thread util dot run timer, and this the duration is going to be called thread util it's going to be thread util dot animate, and then new runnable, and then inside of public void run we just need to go ahead and say player dot set current image to D and false. So after we have them move to the new location, then we want to wait for 75 milliseconds and then set their new image to be whatever the direction is, but then not moving because we want them to be still. Then we are going to go ahead and say if did move, call event. So if they did move, then we're going to have it, and we need to make this false by default, by the way. We're going to go ahead and call an event there. Once we write the event system, it'll just be like a move event, so that if you decide to register it, or if you have a move event, it'll actually call it there. Excuse me. And that's all we need for handle movement. Now, we need to, inside of GUI, we need to have a couple more things. We need to, we're actually going to go ahead and now do the, actually getting the input for the key. So, inside of GUI, we need to define a couple of fields, and it's going to be called, first we need, and we'll put the player down a bit. So we're going to say protected int key press equal to -1. And then that is all that we need for now. Or I guess that's all that we probably will need. Now when we go to check the input, we're going to go ahead and let's do that right now. Write the key listener that will listen for the key. Then in check input, we can use this key pressed field to check what key was pressed. So in frame, we're going to go ahead and right here, we're going to say add key listener, and we're going to use a new key adapter. Key adapter is just a key listener that, if you just use a key listener, then you need to define all three of these methods. But since we only want key typed, then, or I guess we'll probably just use key pressed in this case. Yeah, then we only need that one method, and we don't need to supply the other two. Then we just need to go ahead and say GUI dot set or GUI dot key pressed is equal to e dot get key code. So whenever a key is pressed, then we're setting the key pressed field inside of GUI to be equal to here we go. We're setting it to be equal to whatever the code is of the key. So that is good for there. Now inside of GUI, this key pressed, whenever a key is pressed, that field will change, and now we need to actually, where it says check input in that comment, we're going to actually go ahead and fill that in. So we're going to first say if key press is not equal to -1. If it's -1, it means that they haven't pressed a key, or we've already handled the last time they pressed a key, and we don't want to keep pretending that they pressed that same key if they only pressed it one time. So so if it's not equal to -1, then we know that we're good to do something. If key pressed is greater than or equal to key event dot vk left, and key pressed is less than or equal to key event dot vk down, then we're going to go ahead and say handle movement for direction dot value of key pressed. So what we're doing here is we're saying, if you actually go ahead and take a look inside of key event, or we really want to look here, you'll see that these are defined as left is 25, up is 26, right is 27, and down is 28. So by using those if statements, we're basically saying if it's left, if it's between left and down, which means if it's left, up, right, and down. It's the same thing as saying if it's equal to left or up or right or down. It's just an easier way of doing it. If it's in those bounds, then we're calling handle movement, and the direction is the value of that key. So if it's up, then this value of will return up, and then we will have the correct movement that we want to do. Now, what we're going to do is we're going to say we're also going to implement interacting, and this is going to be where if you press enter, then it will do something. It'll do something there, and we'll have, you know, an interact event and an interact with entity event, so that you can actually register those events and use them. So we're going to go ahead and write else if key press equal to key event dot enter. So if they press, or vk enter, if they press the enter button or the enter key, then we need to go ahead and do a couple of things. First, we're going to surround this into try and catch, and I'll explain that why in a second. Catch exception ignored. Ignored, if I could spell that right. Now, inside of the try catch, we're going to go ahead and say final direction D is equal to player dot get current direction. That's just because we're going to use that variable a couple of times, so just instead of calling it player dot get current direction a bunch of times, just an easier way of doing it. Then we are going to go ahead and say final location, and we'll just go ahead and call this interacted location is equal to map manager dot get instance dot get current map dot get location, and it's going to take an x and a y. The x is going to be player dot get current location dot get point dot x plus d dot get movement dot get x, and then it's going to be just the same thing but with y's. And what we're doing here is we are basically figuring out where the interact is going to be with the whatever's in front of the player. So we're basically figuring out the current location plus whatever the movement is, so that we know where it is and for the x and the y, so that we figure out the tile that's right in front of them at whatever direction they're looking. The reason why we have this in a try and catch is, let's say that they're at the very edge of the map and they press the interact button or enter. Then the location will not exist since it's off the screen and it's not defined, and you would get an index out of bounds exception. We could have it checked to say if it's greater than, or, you know, whatever. Basically, we could do the same thing that we did for here, but we could also just surround it in a try and catch and just ignore if there's an error. It would just, you know, be ignored and nothing bad would happen. So I'm going to be lazy and do it like that. That's why we have the try and catch, and we're ignoring the exception. Then we're going to say if location dot get entity, or interacted location dot get entity, is not equal to null, then we're going to go ahead and call a interact with entity event, and then we're just going to say else call interact event. So what we're doing here is basically, this is going to be where the events are called, and if the entity where the tile is that they interacted with is not null, then they're interacting with an entity, and we want to call a special type of interact event that also contains the entity. Otherwise, we're just calling plain old interact event. And that is all that we need to do for that. Now, this is incredibly important under all these if statements, but before it, this is the end. This bracket right here is the end of key pressed is not equal to -1. We need to say key pressed is equal to -1. If we don't do this, then once they press a button, key pressed will always be equal to that button. So after we handle it, we need to set key pressed to be -1 so that there's nothing that will happen. Or it won't register it a second time unless I actually press it a second time. Let's see if this will actually work. Here we go. Alright, it does work. Now, you'll see that we encountered an error, but it does actually move around, and we did get, it does have a little interaction. So let's go ahead and take a look at where exactly the issue is going to happen. And there it is. Okay. So the issue is when they try to get to the top, they will... If they're at the top and then they try to go up, then this point relative to will return, or it will try to get a location that doesn't exist. So again, let's just go ahead and be really lazy and surround this in a try and catch array index out of bounds exception, or just rather an index out of bounds exception, and we're just going to call it ignored because we want to be lazy and ignore it. And actually up here we might as well catch the array index out of bounds exception, so that we ignore the or just index out of bounds exception. We want to ignore the index out of bounds exceptions But otherwise, we don't want to do that. Crown Comedian asked, what did I miss? We basically kind of finished up the interacting, or the movement, and I showed that it did work. I'm going to push to the repo in just a second, because we're almost done this part, and then we can move on to the event system. So, let's try it now. As you can see, the player can move in all directions, and there is no issue if they try to go off of the screen. And, well, let's just go ahead and show it. They will, you know, rocket across the screen like that. And, there is no problem there. And you will see that if you look, the walk cycle does change. It's not just the same foot pattern each and every single time. Excuse me. It does, change based on the current location in the walk cycle. And also, it doesn't go off the edge, and I can't walk into this water. It will just forever make me butt into this water, and I will be unable to walk into it. So, if you notice that it's a little bit choppy, it's because, and especially when I walk like this, the reason why it's a bit choppy is because, the images, when I got the images, I originally had them as all separate, and then I tried to combine them into one file with, you know, the correct size and spacing and whatever, and it didn't quite work perfectly. So, of course, these are just temporary graphics, just so I can have some graphics, but, don't worry, it does actually work fine, so you don't have to worry there. So we just now added a rock-solid entity class, then a player. We added the player, and we made it so that they could actually move around, and that they will abide by our rules, that they can't walk into things that they're not supposed to, and they also can't walk off of the screen. So I'm going to go ahead and push this, and then the last thing that we're going to do before we end today is write the event system. So give me 1 second. So we wrote the entity class. We, what else did we do? We, added player, and then we, added key listener so that we could get the different input. So I'll just go ahead and push this right now to the repository so that if you're watching live, you can make sure to keep up. And this should just be up here in a second. Alright, there we go. So, wrote entity class, added player, and added key listener. Those all just showed up in the repository, so we are good there, and you can have the latest code with everything that we just did. Now, before we finish today, we're going to go ahead and write the event class, or the event system. Now, this is one of my favorite things that I wrote, and I really think it's pretty cool how I went about handling the events. And we're going to just go ahead and write the framework that will allow you to, you know, have events and call them and listen to them. Because what's going to happen, the way that this game will work, and I find it to be easiest like this, is that you can, basically we're going to have, you know, different classes that represent, let's say, you know, like quests, for example. So if you want to, say, go on a quest where you need to walk to a certain tile, then you would have some method in that class that would start. When it starts, it would register the listener for, it would register a move listener for that given location. Then if the player moves there, then we want to, you know, send them a message and then unregister the listener. So that's how it's going to actually end up working. I find it easier to do that than to actually, like, you know, go ahead and hard code stuff in. It doesn't really make sense. And also, this makes the game modular. If you wanted to support modding, or if you just want to make it easier for yourself in the future to add in more quests or, you know, whatever, you can easily just register more events and it'll automatically work because we have a cool event system. So we're going to go ahead and make an event package. And in here we're going to have a couple of classes. First class is going to be called event. This class represents an event, and it is incredibly complex. You guys ready for this? Are you sure? Done. This is the event class. Now, the only reason why we have this event class is because we need to have all events, because we're going to write a bunch of different classes that extend event. We need to have a common ancestor for all these classes, so we make sure that they're calling the event, but each event is just going to have a constructor and then some getters and setters that correspond to it. Excuse me. So we don't really need anything in here. Now, some things that you could put in here is, have like a method that would return the type of the event if you wanted that for some reason, or any other methods in here. But for now, we actually don't need anything. Now, Ninja Tiger X7 asks an important question: could you make the movement of the sprite smoother somehow? The answer is yes, and the way that you would do that is you would have more of a walk cycle. So right now, we only have foot out, foot in, or foot 1 out, foot 2 out, or still. And if you wanted to have more, then you could add one where foot 1 is halfway out, and then foot 2 is halfway out. Then you would have it animate so that it would first set it to be halfway out, then halfway in, or it would be the same thing, halfway out, and then back still. So then that would just add 2 more frames to the animation, and then over that same amount of time, there would be 2 more frames inside of that space of time, and then it would look more smooth. I'm not going to do that because I don't have the graphics for it, but that is how you would go about doing it, and that's definitely a very good question that I should have addressed. So this is our event class, as I was saying, empty class, that's fine. Then we are going to go ahead and write a listener class, and this part is going to be cool because this event system uses a lot of generics. If you don't know what generics are, I'm going to try to explain them quickly right now. But let's go ahead and make the listener class. This class represents a listener that's listening for some type of event. And it will have a method in it called onEvent that will handle the event. So this listener class is going to take the parameter t extends event. This is generics, and it's one of my favorite features of Java, and it does also exist in other languages. What we're saying here, and you will recognize this from array lists, and that's probably the best way to explain it. So, I guess, where do we have array lists? I suppose inside of row. What we are doing here is when we instantiate an array list and we're giving it location, then we're basically saying this array list, the type of this array list is location. So when we call this add method and we go ahead and take a look, you'll see it takes this e, called e. Instead of taking an object, it will actually, if I give it the parameter of location, and I try to add something like a new string to it, then I'll get the error, or that would of course be an error, but if I tried to call, let's say, locations.add, and then I gave it a string, then it would not work because I'm saying that this array list definitely contains locations, so if I go to add a string to it, it's of course not going to work since a string is not a location, nor is string a subclass of location. Now, of course, if I go ahead and call locations.get for, let's say, 0, it will return a location because I said that it contains locations. If I didn't give this a parameter, then that means that I could add anything that I wanted to it and get anything that I wanted from it, which is generally not what you want to do. So then in that case, add would take any object, and get would just return object. So that's just a quick rundown of generics. What we're doing here is we're taking the listener, and we want to know, each listener will be listening for one particular event. So when we instantiate the listener, we want to know what event they're listening to. So this t extends event is the event that they're listening to, and then, but whatever they give us needs to extend event. So if they gave us like listener string, that wouldn't work because, string's not an event and that wouldn't really make any sense. So whatever they give us has to extend event. So when we make a move event, I could instantiate a listener and then give it the type move event, and then it would, the type of the listener would be, a move event listener. We need to go ahead and define 2 things in here. Private class t event class, and a private boolean should remove. You need to go ahead and do a public listener, and this will take a class t called event class, and we're going to go ahead and say this dot event class is equal to event class. Now what we're doing here is we have this variable called event class, and it is of type class. Now class also can take a parameter, and that basically represents the type of that class, basically, to explain it. So in this case, when we give it this t, so if I give it a move event, then it basically says that this class that I give it has to either be a move event or a subclass of move event. Now the reason why we need to do this is because Java has something called type erasure. What this means is if I try to access, let's say, t.class, and that should be uppercase, like let's say that because we're going to need to access the class of the listener, because in the event dispatcher class that we're going to write, we need to know, what type of event we're listening to. If I try to access this, you'll see that you cannot get anything from a type variable, because what type erasure does is when you, what type erasure means is when you when this gets compiled into, Java bytecode or whatever, this t parameter gets removed and everything's treated as an object. So this only exists in the realm of coding, or in the realm of this type of coding. It will get removed and when it's done. So when we go ahead and call like t.class, this t is not going to exist past right now. When we go to compile it, t will be removed. So all those warnings about adding and removing things only exist here, and it's just used to help you. It doesn't exist past here because of type erasure. So we need to still know what class we're using. So in this case we take class t, which means that it needs to be the class that we're giving it here, but then we actually have an instance of it. And now we need to go ahead, write a couple of methods. Public class t get event class, which will return event class. We're going to use this in the event dispatcher class for, handling events. Public boolean should remove, and then this will return should remove, and then a public void called request remove, and then that will say this dot should remove equal to true. Finally, public abstract void on event, and that takes t event, or not e, t. Now first we need to make this class abstract, and what this means is this class has an undefined method called onEvent. The parameter is t event. So if I make this called if I make this listener listen for move events, then it needs to contain an onEvent that listens for a move event that I'm calling event here, and that is very important. So alright, so we have our abstract void on event, and that's all that we need for listener. Now we're going to go ahead and write the event dispatcher. We're going to write a couple of listeners. We're going to, I think, 3 listeners. We're going to integrate them quickly, and then we're going to finish before I lose my voice. So I've been talking for an hour and 15 minutes straight, and I'm sure that you're all starting to get tired of listening to me drone on in my voice. So, let's go ahead and write the event dispatcher class. This class will basically contain all of the listeners. It'll keep track of all of the listeners, and then it will have an easy way to call the event. So I can call an event from anywhere. First, we need to go ahead and make this a singleton, because it's going to contain a list of all the listeners that we need, and then a method for calling an event. So since we have an instance field or instance variable called, or an array list of listeners, we want to make this a singleton, so we don't need to be static. So private event dispatcher, we're just going to go ahead and here's where we're going to instantiate listeners, which is going to be the array list, private static event dispatcher instance is equal to new event dispatcher public static event dispatcher get instance return instance. So now we have our singleton set up. We need to go ahead and do a private array list listener called listeners, and that's going to contain So first we're going to go ahead and say up here, listeners is equal to new array list of listener. So this is going to contain all of the listeners that are registered, because then when we go to use the call event method, then we need to know all the listeners that are listening to, see if it's listening for that particular event and then do stuff. Alright. So we need to go ahead and first write a register listener method, public void register listener, listener L, and we're going to say listeners.add L. And that's just for registering a listener. Then we need to, this is going to be the most important method, of course, the public void call event, not class, public void call event E. And this is going to be where whenever we want to call an event, like for example, when the player moves, we want to call a move event. So we're going to call this method called call event. I'm using the word call so much. But we're going to use this method called call event, and we're going to give it an instance of move event. Now what we need to go ahead and do is we need to sort through all of the listeners, check if it's listening for this particular type of event. If it is, then we need to call the onEvent method inside of it. If we're supposed to remove it, then we need to add it to a list of things to remove, then remove everything. And this will make more sense as soon as we write the code. So we have an array list of listener called remove is equal to new array list listener for listener L in listeners. If L.getEventClass.equals E.getClass, L.onEvent E, and then if L.shouldRemove, remove.add L. Almost done. One last line. Listeners.removeAll, remove. What we're doing here is we have a list of first, we're declaring a list of listeners, or an array list of listeners that we want to get rid of. Then what we're doing is we're going through every single listener. If the event class is equal to the class that we're giving it. So if I call a move event and I have a listener that's listening for a move event, then this would be true because it's listening for a move event and this event type is move event. If I had an interact event listener, then it would not work because move event and interact event are different. So if it does match, then we're calling on event, giving it the event. You'll notice that you'll get like a raw type thing here. You can ignore that because we know that we're calling with event of the correct type. Not really important, just ignore that. Then if we should remove it, then we're adding it to the list of remove, and then we're removing everything. The reason why we can't just say listeners.removeL is because you will get a concurrent modification exception, or CME. What this means is you cannot modify in a list while you are iterating over it. So we're basically going through all of these listeners, but I can't, while I'm inside of this for loop and going through all the listeners, I can't modify that listeners list while I'm going through it because you'll get a concurrent modification exception. So you need to have a list of everything to remove, add it to the list of things to remove, and then call remove all on that list to get rid of everything. What we're going to do is, let's say that you have it so when it moves to a specific location, it does something. After it does that thing, you probably want the listener to stop happening, or else it'll do the same thing every time you move to that location. So what you want to do there is you would call the request removal, I believe we called it, request remove, which will then set it to be true. So after the on event, it'll add it to the list of things to remove, and then it won't happen again. So you would just inside of the listener call request remove. And that'll make more sense once I write a quick sample listener. Alright, so now we're almost done, and I'm starting to get a headache from hearing my voice for so long, but we just have a couple of more things to do. First, we need to go ahead and write a couple of events. First, we're going to go ahead and write an interact event. Now, interact event extends event, so it's a type event, and it is treated like an event. And now what we need to store in there is the location where it happened. So we need a private location, location, public interact event, location, location. This dot location is equal to location, import the correct location, and then we just want to go ahead and quickly generate a getter. What this is doing is whenever this interact event is going to be instantiated by the code inside of the GUI whenever something's interacted. When I instantiate it, it needs to have a location, so inside of the listener, I'll have access to this getLocation method, and this will make more sense soon. And if you program using Bucket, which I use a lot on my channel, then you will know that this works sort of similar to that, in that you have this instance of an event class that has a bunch of getters that you would want to have. So next we need to go ahead and do an interact with entity event. This is going to extend an interact event because it works just like an interact event, except it also needs to contain the entity with which there was an interaction. So private entity, public interact event. We still need to take, and make sure to import that, we still need to take the location because interact event needs the location, but then we also need to take the entity called entity. Then we're going to go ahead and super location, which will it'll call this with location here, so we set the location, and then also this dot entity is equal to entity. Then we need our getter for entity, and why is this giving us an error? Oh, it's supposed to be interact with entity event. So this works just like an interact event, but it also contains an entity. So we can make it extend interact event so that it'll automatically take care of the getter for the location, but then we also need to have a getter for the entity. Finally, one more event for now, and of course you can easily add your own events, and we might add some more later, is the move event, which will represent when someone moves. And in here, first of all, this is going to extend event. Then we're going to go ahead and store a private location called from. It's going to take a public move event, takes location from. This dot from is equal to from. So we want to be able to know where the player came from. If you want to know where the player went to, you could just call player.getCurrentLocation. So, but we still need to know where they got it from. So, we're going to save that in here so that they can access it. So we need the get from getter. We could just go ahead and write, so we have get from, let's just go ahead and actually add public location get to, which will return frame get instance dot get GUI dot get player dot get current location. So it's just an easier way of getting access to it. Now we are going to write two quick helper methods. Public boolean to is point p. So given a point, it'll tell you if 2 is equal to that point. That's just easy for, like, if you want to check if they move to a specific location, then you can easily check with that. And then we can just say go ahead and return get 2 dot get point dot equals p. And then, it's just shorthand. And then we can just copy that and paste it for from is, and then we can say get from. Now we might as well go into the interact event and say, add something like this, and say, we can add one like this and say point is, and then just say return get location. So it's just an easy way to see if they interact with that specific point, then we can, just have little methods to help with that. Almost done, guys. We're almost there. Alright, we have all of that done. I don't know why that event thing is grayed out, but it doesn't really matter. We need to go ahead and hook in all of these events, and all 3 of these are actually going to be called from here. First, we are going to go ahead and call the interact with entity event, and all we need to do here is say event dispatcher.getInstance.call event new interact with entity event, and this first of all takes the location, which I believe, let's see what location we want that to be. I think we want it to be the, interactive location, of course. That's silly of me. interacted location, and then the entity is just going to be interacted location.getEntity. They could call it themselves, but we're just going to make it easy for them. Or for, I guess it would be you who's, using this actually. So then otherwise we're just going to call getInstance.callEvent. This is just going to be a regular old interact event, and this is going to take interacted location with no entity. Finally, we need to go ahead and call the move event, so we're going to say event special.getInstance.callEvent new move event, and that's going to take to and from. Or I guess it only takes from. So from, remember, we defined up there, so we can use it here. And we're setting it to player.getCurrentLocation, because then when we go to change their location, we want to, call it with their old location. And remember, this will only be called if did move, which is only true if they did move. So that's important, of course. And this should be called ignored. I guess I just spelled it wrong. And I did it right up there. Okay, we now have the event system done. Let's just quickly go ahead and make a package called game. This is going to contain, and we're just going to call this sample listener. And then we're just going to go ahead and say public sample listener. And now, this is where we're going to actually register a test listener. We're going to say event dispatcher.getInstance.register listener, new listener. First of all, the type of listener is going to be a move event. And then we need to give it the class, which is moveEvent.class. And remember, we need to do this because of type erasure. Then, when it says event, we need to make it say move event, which first of all is easier for us, but second of all, actually is necessary. So, inside of this, you'll see that we get e, and then we get from is, to is, get from, and get to. So let's just say if e dot to is new point, and then you could write one that just takes an x and a y and makes it a point, or however you want to do it. Let's say if it is 0, 0, then we'll go ahead and say system.out.println 0, 0. So we're registering a listener where on a move event, if the to location is equal to 0, 0, then we want to print out 0, 0, and then we can just go ahead and say request removed, so that it will be requested that it be removed, and then it won't happen again. We do need to instantiate sample listener, which in the constructor we do everything, so we're good for there. Now let's finally just go ahead and test this, and then we will be done for today. Alright. Ooh. Alright. And we get a Stack Overflow error. Oh, that was just... Okay, it was accidentally calling this method, which I have the variable and method named the same thing, which could probably not the best idea, but it was just the method was calling itself instead of calling a variable with the same name. Not important. Just a typo on my part. As you can see, moving works normal, but if I walk up there, you'll see it prints out 0, 0, which means that, first of all, the event was registered, then the move event was called, and it was of the correct type, that checking the event class for the correct thing did work, and then the is2 method worked with that location. Everything worked, and we did that. Now you'll notice if I go back a second time, it doesn't print out 0, 0 again, because that listener is now removed or deregistered, so it is now gone. And we're good there. Alright, guys. That is all for the super long day 3. I guess we're coming up on an hour and a half's worth of work. We did adding, entities, adding the player, listening for the player's input, and then we added a really cool event system that I made myself, or I came up with it, and I think it's pretty cool. So we're just going to go ahead and push this and say added event system, and I guess we're good there. Now, I know that I promised for 5 days worth of work, and we've already done 4 days worth of work in 3 days' time. I don't know exactly what to do for tomorrow. We do have everything in the game working correctly. I haven't encountered any errors. So what I'm going to ask you to do is, if you can think of an idea for tomorrow, or definitely if you found an error, please leave a comment on the YouTube video. Of course, this only applies, if it's before day 5 or before day 5 is called off. So, just if you have an idea or whatever, just leave it, and then basically day 5 is just going to be fixing any bugs that you guys might find, and then also any of your ideas that you want to add. Now, if they're ginormous, like big, fancy things that we might not have time for, then I might not do it in this video. Maybe I'll even continue this as a non-live series, since it takes a lot of time to do it live, and, you know, and it takes a lot of time for this. Let's see, I just got a request to add music. The issue with music in Java is that there really isn't a great API. I will put that on my list, and I guess we'll do it tomorrow, because I found 2 different solutions for playing music. Both of them work with playing music and sound effects, so I guess I will share that to you tomorrow. Music is one thing that we'll do, and so we'll go ahead and do part 4 or day 4 tomorrow. Make sure to leave a comment with what you want to see tomorrow, or any bugs that you find, which is, of course, the most important thing, and that's what I'll start with. Hope you guys enjoyed today's super long episode, and I will see you guys tomorrow at probably 4 o'clock, or definitely 4 o'clock, with the final day's work. Bye, guys.